Hello. The title of my science fair project is Do Athletes Have Better Lung Capacities Than Non-Athletes? This problem interests and engages me because I'm an athlete myself. I was very curious to see the difference between athletes' lungs and non-athletes' lungs, and to see which category's lungs would be stronger. This topic is connected to the world because of lung health problems, heart rate and beat problems, and lung capacity. My hypothesis for this science fair project is that athletes will have better lung capacity than non-athletes. I think this because these athletes do many hours of training almost every single day. Because of this, they are making their lungs and lung capacity stronger, whereas those who don't work out wouldn't be strengthening their lungs or their lung capacity. This would also be including their heart health and rate. According to and proven by scientists, athletes tend to have an increase in pulmonary capacity, also known as respiratory capacity, is the sum of two or more values. Factors such as age, sex, body build, and physical training and conditioning have an impact on lung capacities and lung volumes. Lungs usually reach maximum capacity in early adulthood, but with age, lungs slowly start to decrease by 40%. This is why in the 60s to 70s range, it is harder to do active activities. Scientists suggest that the outside appearance can be a pretty big giveaway as to who is an athlete or a non-athlete. Athletes tend to be more muscular and less body fat, whereas for non-athletes, it is usually the opposite. A common question that is asked between these two categories is who gets the better school grades and has more time to prepare for tests and quizzes and etc. Research in Minnesota showed that athletes received a 2.84 GPA compared to a 2.68 GPA for non-athletes. Another study in North Carolina found that athletes had a 2.98 GPA compared to 2.17 GPA for non-athletes. According to these studies, athletes had a higher GPA score than non-athletes. The materials used for this project were a pulse oximeter, 10 non-athletes and 10 athletes, papers, pencils, candy, water, cups, and the Science Fair Project logbook. For the procedure, there were 10 athletes and 10 non-athletes. After the athletes and non-athletes finished their exercises, a pulse oximeter was placed on their finger to measure their heart rate of BPM, beats per minute. For the exercises, I had both athletes and non-athletes do 25 squats, 5 push-ups, and 15 jumping jacks. It is easier to add more numbers to the exercises that are easy and to add harder numbers to the exercises that are harder. This challenges your muscles and keeps your heart rate increased. In order for this experiment to work, each athlete and non-athlete had to do the exercises correctly and in the same order with full effort and proper counting. Once done, I wrote down and later on graphed the athletes and non-athletes results in different categories. I made separate categories for the athletes and non-athletes. After this, I created 3 graphs, one graph of the non-athletes and one graph of the athletes' data. The last graph was the athletes and non-athletes' data combined. After testing non-athletes and athletes, there was a very similar general pattern in the heartbeats per minute. However, my hypothesis was correct. The athlete's heart rate was in fact lower than the non-athletes' heart rates. Sometimes athletes would have higher heart rates than non-athletes, and the non-athletes would have lower heart rates than the athletes and vice versa. I think that the results occurred this way because of prior knowledge and research of this topic. Research shows that athletes have stronger immune systems because of all the exercises that add up by the end of the week. In conclusion, this science fair project turned out to be very accurate to the main hypothesis and prior knowledge and research of the topic. The data, graphs, and research all turned out well. If to do this science fair project again, I would use more participants in these main ideas to help expand and succeed the science fair project's potential even further. Thank you for your time.